Today we're doing a little bit of top 20. We're slowing down a gear. Then we'll do some more review. We're not going to test until Tuesday of next week. Today's Thursday. And so we're going to take a little bit of time for the top 20. This one reduces to 2 square roots. I like to make it square root of 25 and the square root of 2, because everybody can look at that and go, yeah, they multiply to 50, and I hope that makes sense. If I go right to 5 root 2, a lot of times people are like, where'd you get that? Okay, so there's my first simplify. Now I got 5 plus minus 5 root 2 all over 20. Then this part here factors, and if you can factor it, you should. So that factors out, and then you got 1 plus minus square root of 2 all over 20. But instead of 20, I'm going to write 5 times 4. Notice I didn't cancel yet. A lot of people cancel too early. Only when you've got a 5 on the top and a 5 on the bottom, then you cancel, and there's your answer. Now, I kind of gave you some hints and talked you through it, but I still bet we only got half of you. I don't know. How many of you had that before I said it? And we're about half, a little less than half. The hardest part, in my opinion, is this part right here, where you had that, and you have to notice there's a 5 in both of them, so you factor it like that. Does that make sense? Okay, that's a critical one that a lot of people get wrong. Okay, next top 21 I want to talk about is the one with the powers. 8a squared b to the third, all of that squared. And if it was just that, it wouldn't be that hard. But then you times by 2. A to the third. Let's just do it that way. There. And I threw in some extra parentheses just to see if that messes you up. So the power rules get a lot of people. And they're not that hard. It's just that you don't use them very often and then you forget. So fundamentally it's like this. If you have a to the third and then you put that to the second, you have to decide, is that a to the fifth or is it a to the sixth? And my favorite way of showing you that is just going, what does squared really mean? That means times itself. And nobody would look at that and think, oh, it must be a to the fifth. Like, it's obviously a to the sixth when you write it this way. So if you're ever trying to decide, do I multiply or add them? Write out what it really means. And then you won't mess it up. Because this kind is a to the sixth, and that means you do multiply this kind. And on this kind, you clearly add them. Okay. All right. So let's see what you got. First off, a lot of people just forget to square the 8. You got to square the 8, and that's 64. So I just probably knocked a few people out right there. And then you times that 64 by 2. I'm gonna wait though. I'm gonna just write 64 here, and then a to the fourth and b to the sixth. Those are the kind where you multiply the powers. Times 2 a to the third. You got to know when you can drop parentheses. If there's nothing you can do in the parenthesis, all you could do is multiply this out. So I multiply the 2 times it. Then I can drop the parenthesis because I multiplied it out. Now, here's not my final answer. Why not? Well, because you got to combine like things. When they're all being multiplied, that and that can go together. 128. And then this and this can go together, and that's the kind you add. If you wanted to just write them right next to each other, it would be a to the 4, a to the third, and that means a times a, and then that'll help you go, oh yeah, I guess it's a to the 7th. And then b to the 9th. No, wait, there isn't another b, my bad. There's just that b to the 6th. I thought there was another b, there isn't. There we go. How many of you had that one before I said it? And again, about half, so a little better than half this time. So these are critical little algebra things you gotta know. In the middle of our pre-calc tests, We expect you to know like powers because it's from the past. All right. I think it's time to move on to the new stuff that you're going to get tested on Tuesday of next week. Let's see if you can do one that looks like this. It's bouncing there and cutting through there. This is at 7. This is at 3. Can you write me the equation for that? There's a classic mistake you want to avoid. That's all I'm saying. Y equals. Iris, tell me one part.
X plus 3. And
Close. X minus 3. No, wait, I'm wrong. This should be a negative 3. It wasn't listed as a negative 3, but it is. So then you are right. Okay, good.
Square it.
And then square it. I bet a lot of people forgot that. It was bouncing there. So it's squared. Very good. And the end of it?
X minus 7.
And is that your final answer?
Yes.
Excellent, but you made a tiny mistake too. It makes me feel better because I made a mistake. You also made a mistake. Look at this.
Oh, it's negative.
Oh, it's negative. I know she wasn't the only one that forgot that. It's going down on the right, so it's negative in front. Be honest, who had that right before I said, that's awesome. That's like 7 of you. That's like a third of you. That's more than I thought. All right, let's do one more like that. It's going to be a double bounce this time. Except it's bouncing from the bottom. Okay, so this is at 4. This is at 8. And this is at negative 5. What's the equation for this puppy? I'm gonna pause for a sec while you give that one a try. If you understand your stuff, you should have it. You get a parenthesis for this one, x plus 5. Did you remember it was bouncing? And square it. Ethan T. This 4 needs a parenthesis. What do I put in there? Excellent. Does it need to be a squared or not? No. All right. Next one is this 8 here. And Alex K., what do you put for the 8?
X minus 8.
And square it. Excellent. And does anybody have anything else to add? There's a negative. Very good. It's going down on the right. You need a negative in the front. Okay. Twist. And give the limits. So by this one, write me a limit statement. It's heading to the left and up. And then put a limit by this one. Sophia, the limit on the left side.
Sorry.
No problem.
What if I put X and then
Under, oh, go to the x now.
the X is negative
X goes to negative infinity is correct. Keep going.
and Y is infinite?
And that goes to positive infinity. Very good. Because the x is going this way, which is towards negative infinity. All right, now this one. Rissy, what did you get for this limit that's going down there? x goes to what? Infinity. And the f of x goes to negative infinity. Very good. Okay, awesome. Next kind. I think a lot of you are going to mess this one up. 2x squared parentheses x plus 1. Graph that one. And if you're like, but I don't know what to do with this. If you want, you can think of that as if it was just an x out there. Do you get that you could think of that as an x plus 0? It's like an x plus 0, except it's just an x. Okay, by the number of alarmed looks I'm getting, I think I'm just going to give you let's throw an x out in front of it. Now, graph that. It's just the same. You just have to think a little bit more about what does that x in front do. So I know everybody knows that negative 1 is on here, but what the heck is that? Well, what makes that part 0? Here, if x equals negative 1, then this thing turns into 0, right? So what makes this part equal 0? If x equals 0. So that's how you get a 0 as one of your x-intercepts. Do you get that? Like if I put a 0 here, doesn't the whole equation turn into 0? And that's the point. They're called zeros. All right. So now, do either of them bounce? No, no squareds. Is it going up on the right? Yep, because there's no negative, so it must be going up on the right. And if it can't bounce, then it has to like go through this. And it has to go through this. And if you think about it, if you multiplied this out, wouldn't it have an x squared as its lead term, which is a parabola? So it makes sense that it would look like this. That's another really critical thing is if you have this thing in factored form, do you know that y equals x squared is the beginning of the show? And then we don't even really care about the rest of it except maybe the y-intercept at the end. But the lead term is such a big deal. Let's do one like that. Here's one where you got x plus 6 squared, and then an x minus 3, and then a negative 4 in the front. That looks really scary. I'm not going to ask you to graph it. I'm just going to ask you, what's the lead term? Because once you know that, you can tell if it's up or down on the right, and you can tell if it's the same on the left. Just figure out the lead term. It's like if you actually multiplied it out, what would the biggest power be and the number on that? For this one, I would like you to highlight what you thought was like involved, like that x squared is definitely involved. Okay, and there's more. Highlight what you thought was involved, write your answer, and then I'm going to have you talk to the kid next to you about what you think the lead term of that one is. Pausing while you give that a try. So here's the other things that you should have factored in. That x and that negative 4. When you put them all together, you'd have negative 4x to the third. Raise your hand if you had that one right. Okay, awesome. Now, do you get it's easy to say that it's going down on the right? You know, because there's a negative in the front. So then, this is weird, but we almost never do this because you don't have a graph for it. But write me the right end limit. Is there any law that says you can't sketch it? No, you could sketch it if you wanted to, but you don't have to. You can just know what it would look like and therefore what the right end limit would be. All right, so I'm going to sketch it just because I think it'll be easier. So that tells me what it does on both ends. It goes down on the right, which is all I really needed to do to be able to do my right end limit. But it's odd, so then it goes up on the left. So then if they ask me for the left end limit, I could do it too. Also, one more pro tip, the y-intercept is a big deal. I didn't make you sketch it, but if you did need to sketch it, you'd put in the y-intercept, which is where x is 0. And you just multiply everything else out. So that's 6, and then you square it, and then you times by -4 makes or 6 squared is 36 times -4, which would be a massive one. And then there's times another negative, makes it some big positive number, is the y-intercept. So if I had to make my graph, as long as it went up on the left and down on the right, and it went through some big positive number for the y-intercept. Y-intercept is where x is 0, right? Okay, so my right end limit is this guy, so then it's lim of f of x as x approaches infinity, the y approaches -infinity. So make a sketch if you need to, but you don't have to. If you just know it's going down, you can be like, oh, the down kind on the right looks like this. That's the right, that's the down part. Okay, so that's enough. And today, it's just simply a review day, and so here's our first problem. Everybody open up the worksheet, looks like this. We'll cut out a couple, keep your life reasonable. So much better if you do homework every night and I keep it small. Because if it's too big, you're not going to do it. So much better if you just do a few problems each night. So please open up the worksheet right now. In a moment, I'll be cruising around making sure you're doing it. All right, here's my first one. The problems are kind of handwritten in there because we wanted to use the same basic questions but change the problems. So we pretty much always ask you, what's the leading coefficient? What's the degree? What's the y-intercept? What's the x-intercept? And then you sketch it. All right. Trent, how do I deal with these? Well, I have a saying on my wall. What do you think I'm going to say? Good. So let's factor it. What comes out of both of these? And then what's left?
X squared minus
25?
yeah, 25.
Okay, it's all right. And then let's do it again, because it factors again.
X plus 5 x
You got it. Do you get that this has 3 roots? A lot of people just forget about this x. It's got 3 roots, which are also zeros, which are also the x-intercepts. There's 3 of them. I got them by factoring. That's why I always say if you can factor, you should. Because you can't look at this and just go, I know the 3 answers. But I can look at this and know the 3 answers. All right. Leading coefficient. I can go back to look right there. Sean Nunez, what is the leading coefficient? It's just the number in the front. I know there's nothing there, but it's not 0.
1.
A 1. There you go. And the degree. Tully.
3.
Correct. The y-intercept is where you put in x is 0. Arrow, what do you do for the y-intercept? Okay, so then what do you get? I put a 0 here and I put a 0 here.
25, -25.
You're timesing by 0 though.
So 0.
Yeah, it's just 0. So what, I know that's confusing, a 0's all over the place. We put in x is 0, and we got y is 0. So y is 0. And in fact, you should put 0, 0, because y-intercepts are points. They're like a spot on the graph. Claire, x-intercepts are where y is 0. So what are my x-intercepts in this case?
X equals 0, x equals -5.
0, -5, and 5. Very good. So now we can graph this puppy. All right. 0, 5, -5. Boy, I wish I had the lead term. Oh, I do. It's this one. Right here. That's the lead term. So then I know it's positive, so it's going up on the right. Are any of these bouncing? Nope, so then you just pass through, pass through, pass through. And it's down on the left. Does that match up? I mean, it's up on the right and down on the left. Does that kind of like match up with what I think it should be? Yeah, it's odd. Odd degrees do that. All right, so there's a little help. This next one, step 1 is to factor out an x, but not just an x. Do you know? Say it if you know it. What do you factor out? 5x. There it is. Factor out a 5x. Now, a lot of people wonder then, so is it still 0? Yeah, think about it. If you put a 0 right there, the whole equation turns into 0. So x equals 0 is one of your zeros. All right, if you get stuck, please come up and ask. But I'm going to give you some relief on not having to do all of these. We're going to skip the last one on the first page, which is that one. If you feel like you need the practice, go ahead and do it. It's not like it's illegal to do it, but you may skip the last one on the first page. And these two, number 1 and 2, but the rest of them are limits, and then this one, I feel like you need another one for practice on that, so I think the rest of them are good. And the teacher made up this question specifically because they wanted you to be ready for the test. Strongly recommend that you try that last question. How do you write an equation that has roots like that? Well, one of them is going to be x plus 3. And there's 2 of the same exact number, which means squared. And then there's more. So there's a little help on the last question. Okay, that's all I got for you for today.